bounded sequence we define bounded sequence. A sequence AN is called bounded if there exists some real number, some real number m positive such that absolute value of an less than equal to m for all n belong to n. See, this is real number and this is natural number. Then we say the sequence is bounded. Example, if I take an is equal to 1 by n, then this sequence is bounded above by 1, bounded above by 1 and bounded below by 0. Bounded below 0. This is one example. The second example, if I take an is equal to n, this is example not bounded above but bounded below by 1 Another example, third example, sin n. What about this sequence? This sequence is bounded above by 1 and bounded below by -1. So these are some examples. The sequence are bounded and not bounded. Now we prove another result, that is if an converges to A and Bn converges to B, then product of An Bn converges to product of A and B. Now, since what we have given, these two things are given, since An converges to A, then by definition An minus A less than epsilon by 2 for all n greater than m1. Same argument Bn. Similarly Bn minus B less than epsilon by 2 for all n greater than m2. Now one more thing, I take generally some positive number, that means some positive number, this absolute value of An minus A, some epsilon, but because I will need something if I divide this number, still it will be positive. So I want to divide this number by some number. I will use it as per our requirement, because we have to prove here, a n b n minus a b. I can write a n b n minus a n b plus a n b minus a b, because this is minus a and b, this is plus, so they will cancel each other. Now by triangle inequality I can write this a n, I take common, a n b n minus b plus, from here I take b common, then a n minus a. Now here we need one more result, that this is bounded. Every convergent sequence is bounded. So suppose this is bounded, that means there exists some m, then less than m is some positive number, and this is bn minus b epsilon by 2. This is epsilon by 2. Here I add m plus 1. Here I take m plus 1, because still it is a positive number. M is positive, 1 is positive, so this is sum of two positive number. Still it is positive. So this thing replaced by this, and this replaced by this, because every convergent sequence is bounded. We know this result. Now we take this thing, this b, the mode of b is some finite number. So this is epsilon by 2, and here I same argument, I make b plus 1. Still it is some positive number, that means I add here b plus 1. Now you see, this is less than epsilon by 2, and same, this is epsilon by 2, that means this is epsilon, and I have to take, because this is after m1, this is m2, for all n greater than m, where m is maximum of m1, m2. So what happened? Some confusion may have arisen in your mind, that how I add this. So this thing we need to clear, because here m plus 1 less than 1, so it is less than epsilon by 2, and same b plus 1 less than 1, so this is also a small number, smaller than epsilon by 2. So this whole is less than epsilon by 2, this whole is also epsilon by 2. So apply one more thing. So this is epsilon. I take m is maximum of m1, m2. This means if a sequence, this means the sequence if this is A, then this is epsilon by 2 into m plus, so here m1, m2, so I have to take the more numbers in epsilon. So this is the result, and from here we get an bn minus ab less than epsilon for all n greater than. So this is the result.